So hello guys. The concept of solubility is one that is definitely not strange to us. We have all dissolved some substances in water and noted if they were soluble or insoluble. Well, in this lesson, we will look in depth at solubility in order to learn its definition and see how to determine the solubility of a substance in a solvent. To start with, the solubility of a solute in a solvent is the amount of that solute in moles that will saturate 1 dm cube or 1000 milliliters of the solvent at that temperature. What this means is that if 3 moles of sodium chloride can saturate 1 dm cube of water, then the solubility of sodium chloride is 3 moles per dm cube. Now, we will carry out an experiment to determine the solubility of copper 2 tetraoxosulfate 6 in water at 15 degrees Celsius. The apparatus and reagents needed to carry out this experiment include 100 grams of copper 2 tetraoxosulfate 6, a beam balance, safety goggles, spatula, and 100 milliliters of water. The scientist starts by taking precautionary measures. He wears his safety goggles and proceeds to begin the experiment. To the 100 milliliters of water in a beaker, he adds some of the copper 2 tetraoxosulfate 6 until he obtains a saturated solution. I am sure that you remember that a saturated solution is one which has as much solute as it can dissolve at that temperature. So, he knows that the solution obtained is saturated because even after stirring it, it still contains some undissolved particles. Next, he weighs the beaker of salt remaining in order to determine the mass of copper 2 tetraoxosulfate 6 that was required to saturate the 100 milliliters of water. Now that he knows the mass of the salt remaining, he subtracts it from 100 grams of salt which he had initially. This gives him the mass of salt required to saturate 100 milliliters of water to be 32 grams. With this value, he proceeds to obtain the solubility of the salt in mole per dm cube. To do this, he first converts the mass of copper 2 tetraoxosulfate 6 used to mole, using the formula mole equals mass over molar mass. Knowing that the molar mass of the salt is 159.5 gram per mole, he substitutes the value into the equation and obtains the number of moles of copper 2 tetraoxosulfate 6 that dissolves in 100 milliliters of water to be approximately 0.2 moles. He does not stop here because he knows that the solubility of a salt is the number of moles of the salt that saturates 1000 milliliters of water and not 100 milliliters of water. To tackle this, he uses the proportionality. If 0.2 moles of copper 2 tetraoxosulfate 6 saturates 100 milliliters of water, then a certain number of moles of the same salt that can be represented as X moles will saturate 1000 milliliters of water. On rationalization of this proportionality, he realizes that the solubility of copper 2 tetraoxosulfate 6 in water is 2 moles per dm cube. If we follow these steps, we too can determine the solubility of any salt in mole per dm cube. For now though, we can summarize this lesson as follows. The solubility of a solute in a solvent is the amount of that solute in moles that will saturate 1 dm cube or 1000 milliliters of the solvent at that temperature. To obtain the solubility of a salt in a solvent, you prepare a saturated solution of the salt at a particular temperature, then determine the mass of the salt required to saturate the solution, then determine the solubility in moles per dm cube. I would love to see you in the next lesson.